Hi guys, I am Divyang from IGCSE on Fingertips. Today we are solving Physics Paper 2-3 of 2022 October-November. It's a 40-mark question paper, contains 40 questions, 1 mark each, MCQ type paper. Let's get started. Okay, so we have the first question. It says a wire approximately 48 meter long has an approximate diameter of 0.3 millimeter. Which measuring instrument can be used to obtain more precise value of the dimensions of the wire? So if it's 48 centimeter long, approximately you can use a meter rule, right? And has an approximate diameter of 0.3 millimeter. So you have to use a micrometer screw gauge. Length of the wire, half meter rule. Yes, this is less than half meter, so that will work. Diameter of the wire, micrometer, which is option C. Then we have question number 2. Velocity time graph. For a car is shown, velocity is in meters per second, time is in seconds. What is the distance traveled by the car in 35 seconds? Now the graph is given for 35 seconds. We need to find the distance traveled for a speed time or velocity time graph. The area is the distance traveled. Therefore, let's find out the area. I can consider this as a trapezium, right? From here to here, right? The length of one side is 35. The length of other side is 10 and 35. So 25. What is the distance between the two sides? The distance between the two sides is 10 units, and half of this will give me the area of trapezium. So what do we have here? We have 35 plus 25, 60 into 5, 300. So for this area, so for this thing, the area is 300. Let's find out the area for this part. That is, what is base? This is a triangle, so I'll use half into base into height. Base is 10, 35 and 25. Height is from 10 to 20, which is again 10. And half of this, so 100 divided by 2 is 50. So 350, the total will be 350 meter. 250, 350, yes. Option B, 350 meters. Then we have question number 3. Which property of body results from the effect of gravitational field on its mass? Weight. Gravitational field has weight, right? Weight is because of gravitational field. So ability to resist change in motion, that's inertia, that's due to mass. Density is volume and mass both. Volume due to its dimensions, weight due to its mass, and the effect of gravity on mass, W is equal to mg. Then we have the diagram shows 4 pieces of laboratory apparatus: balance, measuring cylinder, ruler and stopwatch. Which piece of apparatus are used to find the density of liquid? Density, just I said, that is mass upon volume. Balance can be used to find mass. Volume can be found out by measuring cylinder. Now you might think you need ruler, because if the body is regular shape, you might need to measure its sides. But think about it, even if it's a regular body, it can be dipped into measuring cylinder, half filled with water, right? And you can still get the same volume without even using formula. So you need only measuring cylinder and balance. Balance and measuring cylinder is your answer. Then we have question number 5. A metal rod of length 80 centimeter is pivoted at O. Okay, yes, it's pivoted here. Its center of mass is at its midpoint. 4 pulley wheels are indicated by letter P. The rod is in equilibrium. What is the weight of the rod? Okay, so here what is happening? We have to use the law that if this is in equilibrium, if this is stationary, then the downward force W is equal to the upward force T1 and T2, right? What is T1? Force exerted due to this weight. The force exerted due to this weight is going to be 0.1 into 10, which is 1 Newton. The same goes for other one. Why? The same can go for other one because it is also 0.1 kg. So the force exerted by this weight upwards, right? Here it is downwards. But because the string, the thread is connected, this is upwards. So 1 Newton and 1 Newton, that should be equal to weight. So the weight becomes 2 Newton, right? That is your correct answer, right? 2 Newton is your correct answer. Then we have question number 6. Diagram shows an object moving at a constant speed in a circular path in the directions shown. A force acts on the object to keep it in a circular path. In which labeled direction does this force act when the object is in position shown? Whenever an object is going in circles, the resultant force is towards the center of this circle, which is centripetal force, and therefore option D. Then a force F acts on a body of mass m for a time t. During this time, velocity of the body increases from u to v. Which equation relates F, m, t, u and v, right? So basically it's Fa, right? Sorry, not Fa. Force is equal to mass into acceleration, but they are talking about u, v and t. So I shall write m v minus u upon t is equal to force, right? This is how I can relate it, but denominator is not given, so Ft is equal to m into v minus u, given by option C, the correct answer. Then we have question number 8. An object falls towards the earth's surface. What happens to gravitational potential energy and kinetic energy of the object? Now, the law of conservation of energy states that the energy can neither be created nor be destroyed, right? So gravitational potential energy, because it is at height, right? If it falls towards the earth's surface, it is at a given particular height, and if that happens, right, it has no kinetic energy, or maybe some kinetic energy, but definitely gravitational potential energy is decreasing. Law of conservation of energy tells us that it will be converted to some other form of energy, and for us that will be kinetic energy, right? So gravitational potential energy decreases, kinetic energy increases, and the option B is correct. Then we have question number 9. A skier is pulled up a short straight slope at constant speed by a rope. The tension in the rope is 100 Newton and there is a combined frictional and air resistance force of 80 acting on the skier. The slope is 10 meter long and the skier rises 1.5 meter vertically. So this is 100 Newton. This is 100 Newton, right? It's pulling the skier. This force is 20 Newton, right? That is frictional force. And this length is 100 meter. It is just 10 meter. And the vertical rise in height is 1.5 meter. How much work is done by the rope pulling the skier up the slope? So what is work done? Work done is force into displacement. What is the force required to pull him? 100 Newton. Do not subtract 20 from 100. Why? They are not asking about efficient work done, or they are not asking about actual work done or the actual output. They are saying how much work is done by the rope. Actually, that 100 Newton of work, 100 Newton of force is used to do work, right? So 100 into what is the distance of the distance traveled? 10 meter, right? So 1000 joules should be your answer, right? All other information is to distract you or make a silly mistake. Basically 1000 Newton is the force, work done by the force of 100 Newton to raise this person. In some situation, a force does a work. Which set of condition increase the quantity of work done by the force? Magnitude of force. Okay, so they're asking some forces do work, right? Not all. If force and displacement are perpendicular to each other, work is not done. In which increase in quantity of work is done by force. So if work done increases, distance moved increases, then work is done. Because if force decreases, distance moved decreases, work is not done. There is some resistance, right? One of them remains the same, does not work out. So definitely option C, both of them must be increasing for work to be done. Okay, that's your Answer. A measuring cylinder of cross section area 4 cm square contains 224 cm cube of liquid. Okay, so let's say liquid is filled till here, right? This cross section is 4 and the volume is 224 centimeter cube. The pressure of the liquid at the base of the measuring cylinder due to the liquid is 8800 Pascal, right? Pressure of the liquid is density into gravity into height, correct? Into height. So now let us find out that how do we use all of this. First, what I can do, the base area into height is volume, correct? I can use that logic to find out height. So 4 into height should be equal to 224. I find out that height is 224 upon 4. 4 5s are 20, 6 4s are 24, should be 56. It is 56 centimeter, right? Which is 0.56 meter, because this is in Pascal, so I'll have to use meter. Now 8800 upon gravity taken as 10 and height taken as 0.56 should give you the density of the liquid. So 0 0 get cancelled. 880 divided by 0.56 should give you the 1571.42. So 1571.4. This is the density of the liquid in kg per meter cube. Okay, let's see what is our answer. C. Right, this is the closest round off to 1571.4 kg per meter cube, and that's why we will select this answer. Then let's go to question number 12. We have the pressure of a fixed mass of gas in a cylinder is measured. The volume of the gas in the cylinder is slowly decreased. The temperature of the gas does not change, and therefore the pressure of the gas will increase. Which graph shows the pressure of the gas change during this process? Okay, it's pressure versus time. So the pressure increases versus time. That is shown by only graph B and C. But they are showing that in graph B, at time 0, pressure is 0. That cannot happen. Any gas has pressure by when you start the experiment. Therefore, this is incorrect, and therefore option C is the correct answer. Okay, option C becomes the correct answer. Then we have which statement about evaporation is correct. Body in contact with an evaporating liquid loses thermal energy. Yes, because energy flows from a higher region concentration to lower concentration region, right? So if I have water in glass and water inside the glass starts evaporating, water cools down. But if the glass is at higher temperature, it means it has higher thermal energy. Energy will start flowing from glass to the water. So glass also becomes colder. So option A, a body in contact with an evaporating liquid loses thermal energy. Which change in design of a liquid in glass thermometer makes it more sensitive, faster? It can change its distance faster. It can travel more distance with a small change in temperature. A larger liquid reservoir, right? So small change in temperature, larger distance traveled due to larger liquid reservoir, keeping the capillary size same. That makes it more sensitive. Next question we have, an ice cube of mass 12 gram at 0 degrees Celsius absorbs thermal energy from the surrounding at a rate of 3 joules per second. The specific latent heat of fusion of ice is 330 joules per gram. How long will it take for the ice cube to melt? Okay, for this we will need a little bit of space, right? So what are they saying? That the mass of this particular ice cube is 12 gram. Okay. Now the specific heat capacity, the latent heat of fusion is 330 joule per gram. So let's first find out how much energy does it need. Okay. let's find out how much energy does it need. So I will use that energy is equal to mass into latent heat of fusion. Because this is joule per gram, I don't need any conversion, and this is my energy required. Now per second, the surrounding gives it 3 joules. So time is nothing but energy upon the rate, right? Rate at which it absorbs energy. So 12 into 330 upon it absorbs energy at 3 joules per second. This goes 110 times. So 12 into 110 gives us 1320, which is option B. 1320 seconds are required for this ice to melt. Okay. Then we have, what piece of equipment is designed to produce a type of electromagnetic wave? An electric fire. It emits light. Light is a type of electromagnetic wave, and therefore option A itself is a correct answer. Okay. Then we have question number 17. A passing boat causes a floating object on a lake to bob up and down 18 times in 12 seconds. So frequency of this object is 18 by 12, right? Per second we will find here. The wavelength of the wave created by the boat is 48 centimeter. What is the velocity of these waves? Okay, so velocity is equal to F into lambda. So 18 by 12 into 48. 12 one time, 12 four times. 18 fours are 72 centimeter per second. 72 centimeter per second. Option B is your correct answer. Option B, 72 centimeter per second. Wavefronts are incident on a boundary. What is needed for waves to refract at the boundary? A shiny surface at the boundary? Not necessary, because water waves can also be refracted. Small gap in the boundary produces diffraction. Different medium either side of the boundary in which frequency of the wave is different. Frequency cannot change. Okay, for two waves, frequency, for same wave which refracts, the frequency remains same. It depends only on the source. So different medium either side of the boundary in which speed of the wave is different, which means wavelength will change and therefore refraction will be observed. So option D is your correct answer. Then we have question number 19. A person uses a magnifying glass to look at a stamp. Which ray diagram shows a thin converging lens being used to do this? Now, if you observe here, what will happen? The rays never meet. Okay, in option A. But if you trace them back, you observe that they meet here. The image so formed is a virtual image. Why? Because the rays are not actually meeting. We have projected them to meet. It is upright. It is on the same side of the lens. It is larger. So magnifying, yes. Virtual, yes. And this is how it can be used. Let's see if any other ray diagram can be analyzed here. Okay. Here what is happening? Here the rays are going to meet here, and clearly the size is smaller, cannot be used as a magnifying glass. Here, because this forms at infinity, okay, in this case we see or we say that it forms at infinity. When it forms at infinity and it's real, you cannot observe its image. Okay, you have to place screen by trial and error method, and if the size of the object changes, again that will change. So you're not using at magnifying glass. In magnifying glass, we observe that the image forms on the same side of the lens, not the opposite one. So C is also incorrect, and the ray diagram of D is incorrect. So D cannot be your answer. Then we have question number 20. The diagram shows an object in front of a plane mirror. This is the object. At which labeled position is the image of the object formed? It is formed exactly in front, but equal distance from the mirror as much as the object. So option B becomes your correct answer. Okay. Then we have question number 21. Okay. The diagram shows the action of a thin converging lens on two rays of light. The rays are from the top of object O, inverted image I is formed, which name is given to the distance RS. Okay. So the ray passes through S when being refracted from the lens. It means S has to be focus, and this is the center of the lens. The distance between focus, principal focus, and the center of lens is focal length. Let's see if we have such option. Principal axis, principal focus. They're asking distance, so it has to be focal length. Then we have question number 22. What are they asking? The diagram shows the air molecules in part of a sound wave at a particular moment in time. Which statement is not correct? Earlier there was compression at X. So if wave is going from, wave is going from left to right, yes, the compression was at X. Later there will be rarefaction at X. Yes, this will be rarefaction at X. This part of the wave is traveling horizontally across the page. Yes, we assumed it to pass like this. It may be passing in the other direction also. There is no problem with that. It is quite possible. This part of the wave is traveling towards the top of the page. No, this is a longitudinal wave. So it will be traveling either left or right, not top or bottom. So 22, answer is D. The speed of light in a vacuum is 3 into 10 to the power 8 meters per second. Which value is closest to the speed of light in air? There is hardly any change. Okay. So it should be the same, 3 into 10 to the power 8 meters per second. Okay. This is 8, and that's your answer. Then we have 100-meter race started by firing a gun. The gun makes a bang and a puff of smoke at the same time. When does the finishing judge see the smoke, and when does he hear the bang? He sees the smoke immediately but hears the bang after some time, right? Because light travels faster than sound. You may take the speed of sound as 300, and you can measure after how much time does he hear the bang. But simply because there are no different times given, there is only one set of time given, I can say sees the smoke immediately, hears the bang after some time, which is after about 3 seconds. So option B becomes my answer. Then we have question number 25. A student is to demagnetize a bar magnet. She tries 4 different ways. Hammering the magnet works. Heating the magnet works. Passing direct current through the magnet? No. Alternating current, if you may pass through, it may get demagnetized. Placing the magnet in water? No. It still remains a magnet. So option 1 and 2 are correct, which is your answer B. Then we have question number 26. A student is investigating a resistance wire. She measures the current in a 50 centimeter length of resistance wire. The student repeats the experiment using a 100 centimeter length of the same resistance wire. What is the effect on this change on the current in the circuit and on the resistance of the wire? So current in the circuit, let's comment it afterwards. The resistance increases if the length increases and the wire remains the same, which means cross-sectional area remains the same. So what is increasing? Resistance is increasing. So this cannot be your answers. Now, if resistance is increasing and the battery is same, the current will decrease because V is equal to IR. So current decreases, resistance increases. Option B is the correct answer. Then we have question 27. A resistor is connected to a cell so that there is a current from positive terminal of the cell to negative terminal. What causes the current in the resistor? Electron moving from negative terminal to positive terminal. Yes, this causes the current. This is correct. This causes the current. So option A is the answer. Then we have question number 28. Plastic rod is rubbed with a dry woolen cloth. Rod becomes positively charged. Which statement is correct? Electrons move from cloth to rod. Rod becomes positively charged. So electrons must move from rod to cloth, right? It must lose electron from rod to cloth. Option B is the answer we are looking for. Then we have question number 30. Which combination of current in a resistor and the time for which it is present results in charge of 240 coulomb passing through the resistor? So 240 coulombs. Okay, current is given. So sorry, Q is equal to I multiplied by T, current into time. So 12 to the 24, and option A itself gives you 240 coulombs of charge passing through. So option A is the correct answer for 29. Then we have each potential divider is placed in a circuit with power supply. Which potential divider makes the potential difference across component Y increase when the light intensity increases? So what is this? These all are light dependent. Okay, these two are light dependent resistor. So if light intensity increases, the resistance decreases. If resistance decreases, the voltage drop across this component decreases, and therefore voltage drop across the other component must increase, and therefore option A, right? The voltage drop across Y will increase if the light intensity increases, and therefore option A is your correct answer. Then we have question number 31. Okay, there is a diagram. Let us set this diagram here. We have question number 31. Two resistors R1 and R2 are connected in series in a circuit as shown. The current in resistors is I0. They are in parallel. Okay. Another resistor R3 is then connected in parallel with R2 as shown. Okay. How does the current I1 and I2 and the resistance R1 and R2 compare to I0? Okay. So what happens if the cell remains same but one resistor is added? The total resistance of this whole circuit decreases. Okay. Assume this to be 1, 1. Right now the total resistance is 2. Assume these to be 1, 1 and 1. The total resistance here becomes 0.5, and therefore if I add 0.5 and 1, I have 1.5. So the resistance is 1.5 here and 2 here for the same arrangement. How does the current I1 and I2 in the resistor R1 and R2 compare to I0? So I1, the total current, will be greater than I0. Okay. Is there anything else they are asking? The current R1, I1 is greater than I0. So option A and B cancelled. I2, right, because the current is dividing here, right? So it will be less than I0. So option D is your correct answer. Then we have question number 32. Okay. Let's see. The diagram shows a circuit containing a cell, a lamp and 2 ammeters. The current reading on the ammeter 2 is 0.2. Current reading on ammeter 1 will become 0.2. What is the name of this type of circuit? Series circuit. And what is the reading on ammeter 1? 0.2. So option A itself is your correct answer. Then we have question number 33, which is not in syllabus, right, from 2023. So let's not even think about such question. If you want worksheets, you can visit our community page. I have given a worksheet for space physics. It may help you in your revision. Okay, let's see now. 4 small compasses are placed on around a solenoid. The current is now switched on in the solenoid. Which diagram shows the possible new direction of compass of the needles? Okay, so there are only 2 possible ways magnetic field lines can be formed. Okay, one is this, right? It goes from north to south. This becomes north, this becomes south. Okay, and the other one is, so let's just draw. The other one is same thing but like this, meaning this becomes the north and the other side becomes the south. Okay, now let's see in this case what will happen and in other case what will happen, that we will see through the needles. Now if in any of the case that has formed, the needles cannot face the magnet, I mean temporary magnet, right, electromagnet. It has to focus either left or right, because the magnetic field lines, as I showed you, are either left or right. So B is also not possible. C, they cannot be in opposite direction, not possible. D, yes. See, the magnetic field lines in this one are going like this. Okay, the magnetic field lines are going like this, and therefore the compasses are aligned like that. And your option, therefore, correct answer is option D. Okay. Then we have question 35. Which metal is used for core of a transformer? A metal that demagnetizes easily and is a magnet. Soft iron. Right? We use soft iron core. So question 36 we have. The diagram shows a conducting metal rod PQ in the magnetic field between the North Pole and the South Pole. Rod is connected to a resistor in a circuit. In which direction should rod PQ moved to induce current I in the direction of arrow in the circuit? So what is this? This is a generator. For a generator we use right hand rule. So let me come here. Right hand, the first finger must point from north to south, so it is pointing. The second finger must point in the direction of the current. Now they are saying that the current must go from P to Q, correct? If it does go from P to Q, right, this is the direction, and this thumb will give the direction of motion of the conductor, which is A. So option A becomes our answer. Then we have question number 37. A thin metal foil is placed in a vacuum. Alpha particles are fired at the foil and most go straight through. A very small portion of alpha particles are deflected through large angles. What does this provide evidence for? It provides evidence that alpha particles, if passing through, the positive charge that can deflect alpha particle is really small. What is that positive charge? It is nucleus, the protons inside the nucleus, and it's really small. Okay, alpha particles are very small. We already knew that. That is why we did this experiment with alpha particles. There are negative electrons in each atom. We did know that. There is tiny nucleus in each atom. That is what we found out, and neutrons were discovered way after that. The table compares alpha radiation, beta radiation and gamma radiation. Which row is correct? Alpha radiation is the most ionizing radiation, beta radiation is a electron, gamma radiation is a electromagnetic wave. So alpha is more ionizing than beta or gamma. So option B and D not possible. Beta is not a proton and therefore C is your answer. Now if you read about it, gamma is electromagnetic radiation and therefore this is the correct answer. Then we have question 39. A high voltage power supply is connected to a metal grid and a wire as shown. When the radioactive source is placed near to the grid, sparks are observed in the position indicated. Here they observe sparks. Which statement explains why sparks are formed? Because alpha is a highly ionizing radiation. It is ionizing gas particles and therefore these sparks are seen. So alpha has a long range. No, it has a short range. It has no charge. It has a +2 charge. Alpha have no mass. It has a 4 relative atomic unit mass. Alpha particles are strongly ionizing and that is your answer. Then we have question number 40. A student investigates 4 different radioactive isotopes. Student places a detector near each radioactive material. The background rate is 36 per minute throughout the investigation. Table shows detector reading at start and after 8 hours. Which isotope has half-life of 4 hours? The one that has half-life of 4 hours, right? It is present, like let's say its emission is X, right, at the start of the experiment. Then the emission present is X minus 36, right, because we subtract the background radiation. Then divide this number by 4. Whatever answer you get, add 36 to it. This gives you the radiation required. So let's find out which one of these options can do that. So 150 minus 36 gives me 114 divided by 4 gives me 28.5 plus 36 gives me 64.5, which is not 36, right? So A is not our answer. Next, 212 minus 36 divide by 4 plus 36 gives me, sorry, it gave me 4. I did something wrong. So 212 minus 36 divide by 4 plus 36 gives 80, and this is 53. So not our answer. Then we have 260 minus 36 divide by 4 plus 36, that is 92, and hence C is the radioactive isotope that has half-life of 4 hours, right? I hope you understand the answer. I hope you understand the paper. If you have read or got any doubt solved through this paper, please leave a like. Thanks for watching. Have a nice day. Bye bye.